Welcome to your 7D notes on average rate of change. The average rate of change will hopefully be something that is easy for you because it's really a review of something you have already learned before. The average rate of change is just the slope of the line between 2 points of a function. So previously when you learned slope, you learned how to find the slope between 2 points on a line. So here is a line with a slope of 1. And on a line, that means every time you move over 1 square, it goes up 1 square. And it'll always and forever be that way. Average rate of change is going to be just a little bit different in how it looks on the graph. So I will give you an example. Let's say that you're driving and you drive 20 miles per hour for the first couple hours. Then you drive 40 miles per hour for the second 2 hours. When you find the average rate of change between the beginning and the end, what you're finding is the slope of this line right here. And I feel like it's pretty easy for you to say that, okay, between 20 and 40, it's going to be 30 miles per hour will be what you end up finding, that you went 30 miles per hour. Well, that's true, but you never actually went 30 miles per hour on your trip. You went 20 miles per hour and then you went 40 miles per hour. That's the way your average rate of change is going to be, except we're going to do it with parabolas, so it's going to be things that are curvy. So it really doesn't make any sense to find the slope of lines because it's curvy. It's going to be really hard. So we just find the slope, just like we always have, on that curve. Here's how you find the slope or average rate of change. You can use this formula, y1 minus y2 over x1 minus x2. The way that you remember this is yx. So you're going to put y minus y on top, x minus x on the bottom, and then you just put a 1 and a 2 on both of them like you're counting. That's how you write your formula. The other way that you can remember it is just simply change in y over change in x. And sometimes it may be more useful to think of it this way, that it's change in y over change in x. And same thing, you're going to think yx, and that's going to be how you remember it. So we're going to find the average rate of change for this function. And it's a little confusing, so follow along with me here. Find the average rate of change for this function on the interval. Remember, this is interval notation, 1 to 3. So whenever we're talking about interval notation, it's always talking about the x's. So this is going to be the first x value, and this is going to be the second x value. So I'm going to write x1 and x2. So we're going to find the points that are at 1 and at 3. So this is the point 1 and then some value for y. We don't know what it is yet. And this is going to be the point 3 and some value for y. We don't know what it is yet. To find out the value for y, we're going to use our function. This function is a formula that gives us how to find y when we know x. So we're going to use this formula twice. To find y1, we're going to do f of x1 or f of 1. That of 1 just means that you're going to plug in 1 everywhere you see an x. So we're going to write our function. So this guy, you're going to refer to that guy very frequently. We're going to write our function, but everywhere you see an x, write a 1 instead. Okay. So you could plug this directly into your calculator. I'm just going to do it. So if you are plugging it into your calculator, a couple points you should note are that you should keep everything in parentheses so that you end up keeping all the operations. Things multiply when they're supposed to multiply, they add when they're supposed to add, etc. The other thing is that if you don't know how to enter in this little 2, there are 2 ways to do it. You can either find the x squared key on your calculator, it'll look like that, or you can hit caret. It's either going to be a button or it's going to be above a button, and then hit the 2. So there's two different ways to get that little 2 over there. Okay, so I'm just going to do it, and hopefully you can just follow along. All right, there we go. So we're going to, I'm just going to do this one. Okay, we'll do exponents first because it's PEMDAS, right? So 1 squared is just 1. So I'll put 2 times 1. I actually want to change ink so you know I'm evaluating. So I'm going to change to a different color. We'll do green. So this is 2 times 1 minus 3 times 1 is 3 plus 4. So that's going to end up being 2 minus 3 plus 4, which equals 2 minus 3 is negative 1, plus 4 is positive 3. Okay, so our first y1 equals 3. So I'm going to go over to my x1, that was 1, and I'm going to put a 3 in where that question mark was. Because for me, sometimes it really helps for me to have it written as a point. Okay, so now we're going to find out our y2. So our y2 is going to be whatever corresponds with our x2. So it's going to be whatever happens when we plug in a 3, because that was my x2. So I'm going to write my function just like I did for my y1. I'm going to write my function with all my x's replaced, this time with a 3. All right, now you can plug this in your calculator and just get whatever answer. I'm going to go ahead and figure it out. So 3 squared is 3 times 3, which is 9. And then 3 times 3 is 9. And then we got that. So 2 times 9 is 18 minus 9 is 9 plus 4 is 13. So I'm going to take that. That's going to be my y2. So I'm going to go put that in where my question mark was over here. Okay, so after all that work, which actually isn't that bad if you're using a calculator, I now have my x's and my y's, and I can plug them into my formula. So really your first step is to find your x1, your x2, your y1, your y2. And on this problem, it took a long time. Sometimes they're automatically given to you. So now we're going to take our formula and we're going to plug in the values and see what we get. I have y1 minus y2 over x1 minus x2 is my formula. Now I'm going to plug in my values. So I had my x1, oh guys, there's so many numbers. So we're going to write, I'm going to write my points up here. 3, 13. I know this is an x, this is y, this is an x, this is y, and I'm going to just choose one of them to be first. And I already had it over here, but I'm like losing track. So this way I have them all really close to me and I can just plug them in. Okay, our y1 is 3, so I'll put that in. Our y2 is 13. Our x1 is 1, and our x2 is 3. Okay, you got to be careful on this. 3 minus 13, you're going to be tempted to say that it's 10, but 13 is bigger than 3, so it's actually negative 10. I would recommend, if you don't know, plug it into your calculator so that you don't make a mistake. 1 minus 3 is negative 2. Then we need to simplify. This is negative 10 divided by negative 2. A negative divided by a negative is a positive, and 10 divided by 2 is 5. So our average rate of change is positive 5. All right, that was kind of a bit. On problems like this where it says evaluate it for this function on this interval, you have to find what the y values are, and then you can plug everything into your formula. Now, example 2 is a little bit easier. It might take a little bit of interpretation though. The length of a lizard is measured for the first month starting when it hatches from the egg. Below is the chart with the day and length of the measurement. Find the average rate of change from day 5 to day 20. So first off, it says from day 5 to day 20, and I have 4 different days. So I'm going to highlight the ones that I'm focusing on, day 5 and day 20. Those are going to be my 2 points that I'm using for my formula. So if you're going to use your formula, you need to know what is x and what is y. Generally, our charts are written like this. where x is on the left and y is on the right. If it's not written that way, generally time, something to do with time, is going to be your x value. So now I have my x1s and my y1s. I'm going to write them as points because that's how I wrote them before. 5, 8, and 20, 13. Here's my x, y, x, y. Choose one of the points to be first and the other to be second. Okay, so now we need to plug it into my formula. All right, we have y1 minus y2 over x1 minus x2. And when I plug things in, I'm going to get 8 minus 13 all over 5 minus 20. Okay, 8 minus 13 is negative 5. 5 minus 20 is negative 15. A negative divided by a negative is a positive, and 5 divided by 15, So this is where you're going to have to think. You can always divide the top and bottom by the same number. And I'm going to divide both of them. They're both divisible by 5. So 5 divided by 5 is 1, and 15 divided by 5 is 3. So this is equal to 1/3. We generally write our slopes or our average rate of change as a fraction. So another way that you can think of this, that's the formula way. The formula way will always work for you, but it might be a little clunky. And if you plug something in wrong, you could easily make a mistake. So I'm going to show you a different way. If you don't like this way, that's okay. Don't do it. Remember that we can also think of slope as change in y over change in x. So I'm just going to look at my table, and I'm going to look at my y values and see how they change. From 8 to 13, what happens? Well, it goes up, and it goes up 5. Okay, for my x values, from 5 to 20, what happens? Well, it goes up, and it goes up 15. So my change in y over my change in x is it went up 5 over 15. So then I can simplify and say divide by 5 on top and bottom, and I get 1/3. So that way was a little faster. You are going to have to remember that it's y over x, and you are going to have to think, like, you have to actually be thinking from the top value to the bottom value, from the top value to the bottom value. And if you switch them, you could make a mistake. So whatever way makes it easier for you, do it that way. Okay, so now we are going to do example 3. This one, the table is not given to us, so we have to find all the y values, and we have to find the average rate of change on the interval. Remember, this is interval notation, -1 to 2. So this is going to be our x1, and this is going to be our x2 when we figure it out. First, let's fill in the table. When I fill in tables like this, I find it's a little easier to show your work in this way. So you're going to show your work in this box right here where it says f of x equals blah, blah, blah. And then you're going to put the final answer that you get for y over here. And then that way it's really easy to check your work. So just like before, I'm going to plug in the x values in everywhere I see x in my function. Okay, I'm just going to write them all out. Okay, this one's going to be 0 squared plus 5 times 0 minus 4. This one's going to be 1 squared plus 5 times 1 minus 4. And you might be feeling confused. I just wanted to save myself some time. So all I'm doing is plugging it in like it is in the function, except everywhere I see an x, I'm going to replace it with the number in parentheses. Okay, so now on our first one, you can plug this into your calculator to get y. The one thing that I would be careful of is that you do need to keep the number in parentheses, particularly with this first one. -2 in parentheses squared does not equal -2 squared like that. This one means negative 2 times negative 2. This one means 2 times 2, but make that answer negative. This is a positive answer. This is a negative answer. So be careful. Always put your parentheses. All right. So we're going to go over here. Negative 2 squared is 4 minus 10 minus 4. So this is like 4. 4 minus 4 is 0, so those two cancel. This is going to be negative 10. Negative 1 squared is 1. Plus 5 times negative 1 is negative 5 minus 4. That's like negative 9 plus a 1. It's going to be less negative, so negative 8. Now remember, you can plug all this in your calculator. So if my doing the math out loud isn't helping you, that's okay. 0 squared is 0 plus 5 times 0 is 0 minus 4. Well, 0 plus 0 minus 4 is just going to be negative 4. Okay, 1 squared, 1 times 1 is 1. 5 times 1 is 5 minus 4. Okay, 1 plus 5 is 6 minus 4 is 2. Okay, 2 squared is 4. 5 times 2 is 10. 4, oh look, 4 minus 4 is 0, so those cancel, so this is going to be 10 again. I like it when that happens. 3 squared is 9 plus 15 minus 4. Okay, this one's going to be 9 plus 15 is 24, minus 4 is 20. Okay, so I found all my y values. Now I need to find the average rate of change from negative 1 to 2. That's kind of how I read that, is from the first number to the second number. So we're going to go to our negative 1 and our 2. I'm going to write those as points so I can better write my formula. Negative 1 is negative 1, 8. And 2 is 2, 10. Oh, negative 1, negative 8. I almost did that terribly wrong. 2, 10. Okay. So then we're going to, you can either do the formula way or you can do the table way that I showed you up above, where you just say from this one to this one what happens. Okay. On this one, because there's so many negatives, I would probably recommend you do the formula way and use your calculator. So we're going to use our formula, y1 minus y2 over x1 minus x2. I need to figure out what my y1s and stuff are. So I'm going to go over here and I'm going to write xy, xy, pick one of them to be the first point and the other one to be the second point. Then we're going to put in negative 8 minus 10 over x1 is right there, negative 1 minus 2. Okay, so let's find out what that equals. Negative 8 minus 10, I would recommend you probably check this in your calculator, but it's negative 18. And negative 1 minus 2 is negative 3. A negative divided by a negative is a positive, and 18 divided by 3 is 6. So the average rate of change on this guy is 6. And once again, you could do this the way where you go, okay, from negative 8 to 10, how does it change? It may be really hard for you to think that that actually grows 18. So that's why I might recommend that you stay with the formula method. From negative 1 to 2, that's growing 3. But if you're having a hard time with the negatives, I really recommend that you stick with the formula. Okay, we have one more example, and this time it's on a graph. I really like this example. So we're going to find the average rate of change on negative 2 to 2. So we're looking for where x is equal to negative 2 and 2. So we're looking on, remember that this axis is the x-axis and this is the y-axis. So we're going to find where x is equal to negative 2, so 2 to the left and 2 to the right. And those points are actually the points on the function. So you can find those points on here and do the whole formula. However, I want you to pause for a second and just draw a line and think, what is the slope of that line? How is it changing? Is it going up? It's not. So this line actually has a slope of 0 because it's flat. So now I'm going to show you the formula way. If you don't look at it and go, yeah, that's a slope of 0, we could do the formula. Okay, so I'm going to find out what these points are. This one's -2 and the y value is 0. And this one is 2 and the y value is 0. Now I'm going to plug it into my formula. So y1 minus y2 over x1 minus x2. So what's really important, what a lot of people mess up on this one, is they mix up, they'll put like their y's first and then they'll swap which x is first. So that's why I always label first before I do it. So you always want the values, the coordinates of your point to match. They're both going to be 1s or they're both going to be 2s. So now we're going to go ahead and plug those in. Okay, so y1 is 0 and y2 is also 0. That's nice. x1 is -2 and x2 is 2. So now when I put this in, it's going to be 0 over -4. I would recommend anytime you have a 0 in a fraction that you plug it in your calculator. You go 0 divided by -4 and then have what it equals. It reads this number divided by this number. However, anytime you have 0 on the top, your answer will equal 0. So this one has a slope of 0. And it's kind of interesting because what this average rate of change is saying is that it didn't change really at all, but it did change, you know, like it went down and then it came back up. But if you were to go, if you went someplace and then you went back, like your net change, how far you actually went was 0, even though your legs went a couple miles. You know what I mean? Okay, so good luck today. Hopefully it goes well for you.